Welcome back to The Explainer. Today, we're arriving at a truly thrilling series conclusion. Over the course of our previous discussions, we've been exploring some pretty heavily abstract ideas about the nature of our universe, specifically the ontological physics proposed by Dean A. Kulik. But today we are taking those highly abstract concepts and slamming them right into the hardest, most rigorous empirical evidence out there. We're going to synthesize Kulik's fluid computational substrate with the absolutely explosive, arbitrary precision computational data that Akiva Groskin published back in May 2026. So buckle up, because the collision of this theory with that hard data has implications that are, well, nothing short of reality bending. Okay, let's dive into this. I really want you to let the question here sink in for a second. What if the physical chair you're sitting on right now, the screen you're looking at, literally the cells in your own body? What if none of it is a static object in the way we usually think about it? I'm asking you to completely rethink physical reality here. What if what we call macroscopic matter is actually just a persistent, cyclic loop of mathematical operations? Basically, a frozen computational state, perfectly locked into a discrete lattice. In this explainer, we're going to look at the hard data suggesting physical mass is exactly that. It's math that has just settled into an unyielding geometric fold. So here is our roadmap for today. First up, the coherence cost. Second, super-exponential reality. Third, smoothing the native fold. And finally, zero-point harmonic collapse. Let's get right to it. Section 1, the coherence cost. To really grasp how reality compiles, we need to start with a massive paradigm shift. Let's contrast our legacy view of reality with Kulik's typeless universe framework, what he calls the phase demodulation ontology. We were all taught the old textbook framework, right? The universe moves sequentially from low to high entropy, and mass is this fundamental thing that actively curves the fabric of space-time. But Kulik's framework flips this entirely. The Big Bang wasn't some low-entropy origin point. It was actually just the first read of a fully compiled substrate, meaning entropy is already at maximum structural capacity. So what exactly is time then? Well, time is simply the compilation depth of the universe running its computations. Time is just the read arrow. And mass? Mass isn't a fundamental noun. Actually, scratch that. It's more like a verb. It's an active, ongoing, local perturbation in a universal carrier field. So the crucial question becomes, how does this system maintain itself without just falling apart? And this brings us to the live law. Put simply, any system, whether it's a digital algorithm running on a server or a biological cell in your body, has to spend energy to maintain its structure against the chaotic, active, running background of the universe. The live law states that the cost to maintain this coherent state naturally decays as the computational loop gets deeper. Think about a physical object, like a chair, or even the human body. The reason they're stable is because they've compiled so incredibly deeply over time that the corrective energy, the coherence cost, to keep them stable has dropped to practically zero. They basically survive the running against the holding. Now, if you're sitting there thinking this is just some abstract, pie-in-the-sky cosmological philosophy, think again. This exact mathematical law governs 5 completely independent technological and physical domains. We're talking researchers working across deep residual neural networks, online learning protocols, and neuromorphic hardware. They all independently discovered this exact same scaling behavior. They built these systems in entirely different decades for completely different purposes, and yet they all hit the exact same geometric constraint. That is not a coincidence. It's a fundamental measurement of how structured logic survives in literally any computational substrate. And here it is, the exact mathematical cost of existence. 1 over the square root of depth. The coherence cost, which is the required thermodynamic gain strictly necessary to propagate a valid structural signal, scales exactly with the inverse square root of the overall computational depth. As time accumulates and depth grows, the cost of keeping a compiled state coherent shrinks. It's this brutal, beautiful, totally inescapable mathematical reality that bridges artificial intelligence directly to the physical universe itself. Section 2, Super-Exponential Reality. Now that we've got the universal law down, let's look at the hard mathematical evidence. Now, what's really interesting about this slide is the sheer, mind-blowing scale of the convergence. Groskin implemented the Combs-Van Swiel-Kolm truncated wild quadratic form, which is a massive spectral operator computation. Just look at the staggering trajectory of the absolute error here. For the first zero convergence, at a cutoff parameter of 13, the error is roughly 2 times 10 to the negative 55. I mean, that's already incredibly precise. But as we increase the cutoff to 67, the error shrinks monotonically down to 1.5 times 10 to the negative 168. That is an incomprehensible 113 order of magnitude convergence across 15 prime cutoffs. And it gets crazier. When Groskin pushed the bounds to cutoff 100 with a basis size of 250, he recovered the Riemann zeros to between 307 and 329 matching digits. The stability of this computational matrix is absolutely jaw-dropping. But here is where the data completely shattered all expectations. Based on the measurements up to cutoff 67, the empirical prediction for the minimal eigenvalue at cutoff 100 was about 245 orders of magnitude in decay. But when Groskin ran the actual test at cutoff 100, the observation exceeded that prediction by 49 orders of magnitude in the direction of faster decay. As Groskin stated, and this is a huge deal, this is, quote, a clean falsification of the pure power law functional form, end quote. The universe isn't just converging, it is converging super-exponentially. It's actively and violently pulling toward a deeply isolated quantum chaotic continuum limit. Section 3, smoothing the native fold. So how on earth does this spectral framework handle all these massive prime cutoffs without just exploding into chaotic noise? Well, this brilliantly illustrates the structural mechanisms hidden inside the math. The Sobolev Regularity measurement reveals a clear saturation floor, while simultaneously the eigenvector overlap remains universally above 0.9498 across 105 different cutoff pairs. Okay, so what does that actually mean for us? Think of the ground state eigenvector as the foundational structural blueprint of the whole system. Despite the internal energy values, the eigenvalues, differing by a massive 113 orders of magnitude, that structural blueprint doesn't change. It means the mathematical foundation absolutely refuses to mutate. As you add prime cutoffs, the system just smooths its needed fold. It doesn't break under the immense pressure, it just sharpens into a clearer, more resolute version of itself. And this remarkable convergence behavior is neatly captured by the empirical Sobolev scaling law. S of C is approximately 55 times the natural log of C minus 128. This isn't just arbitrary algebra, guys. This scaling law acts as the empirical convergence exponent. It literally proves that the universe's structural foundation is governed by highly specific, mathematically rigorous boundaries. To put it simply, if this exact equation didn't hold true, the infinite variance of the universe's computations would cause matter as we know it to literally dissolve into chaotic static. This equation dictates exactly how the firmware of the universe maintains a stable geometric identity instead of just bleeding out into random unstructured noise. Section 4, zero-point harmonic collapse. We've seen the theories and we've seen Groskin's explosive data proving the stability of this substrate. Now for the climax. Let's look at how abstract mathematical computation physically transitions into the solid matter we can actually touch. This is called zero-point harmonic collapse, or ZPHC. It is the terminal ontological event, the exact moment unfinished math becomes physical mass. Here is how it happens. Step 1. The system's recursive coherence is continuously monitored until suddenly, boom, an entropy spike, an omega peak occurs. The math starts getting chaotic. Step 2. The substrate's kernel audit loops apply a massive restorative geometric force. They drive the energies aggressively back toward a specific universal harmonic constant known as the Mark I attractor, which sits at roughly 0.35. Step 3. Any chaotic, unreflectable mathematical residue that just doesn't fit is irreversibly compressed and forcefully ejected out of the loop as an entropy token. And finally, Step 4. With the chaos completely expelled, the informational stress instantly drops to zero. The suspended quantum potentials violently snap into rigid, observable alignment. This right here is the birth of physical mass. Macroscopic matter is simply unresolved computational chaos that is forcefully solidified onto the geometric grid. And that leads us to this final, truly profound realization from the Kulik framework. If matter is just math that successfully navigated the coherence cost, if the universe is really just a substrate perfectly aligning its structural blueprints, then truth is not just some human language corresponding to an external physical reality. Truth is simply achieved phase lock. Your biology, the gravity holding you to the earth, the screen in front of you right now, it is all mathematics perfectly locked into a resonance state, surviving the running against the holding. It really makes you wonder, doesn't it? What other equations are currently compiling all around us, just waiting for the exact right moment to collapse into our reality? Thanks so much for joining me on this explainer. See you next time.